So this is the second part of lab number 5. I hope you were able to watch the first part of lab 5, which it was basically an overview. I'm just gonna go over these configurations just to make sure that all the commands are loaded in each of the four multifunction switches, right, that are serving as internal routers. So in this case, let's take a look at, let's just start with the spine 3. So let's find spine 3. It's right here. So I'm gonna log in admin, lowercase admin, and then I'm gonna log in switch 4 or router 4. So let's go ahead and type admin, and then let's go ahead and take a look at switch number 3. Let's go ahead and do show run configuration compressed. Let's go straight to the VLANs and loopback interfaces. So I'm checking. The first thing that I see is that, yep, we have the loopback 1 not shut down. There is an interface loopback 0. In this case, loopback 0 for this switch 3 is going to have the IP address of 1113/32, which is a loopback address identifying that router into the BGP process, and basically that IP address is set on this switch right here. If I keep on going down on this particular lab, there was no need to configure the interface management or the management interface, and this is the IP range that I mentioned on the previous part 1, and all these ports are in VLAN 1. And if we look at interface Ethernet 112, which is going to be this one right here going down to leaf 1, for example. So that particular Ethernet interface 112 has the IP address of 172.16.3.130. So that's checked. Let's keep on going, scrolling down. Now let's take a look at interface Ethernet 113, which is going to be this one right here on switch 3, router 3 going to, I'm going to just call them routers, from router 3 going down to router 2, for example, and that particular interface is 172.16.6.130, which is this one right here, checked. The next step to configure this spine 1 is to configure the router Vgp. In this case, the autonomous system is going to be 65021, which is right there. That is going to be the autonomous system because on this lab we're using Ipvgp, which stands for external VGP, external border gateway protocol. And then another thing that is part of the VGP configuration is to specify the address family type of the IP addresses that we're going to enter for these interfaces. Like, for example, interface that is a 112 and that is a 113, and as well as the loopback interface. So once we say, hey, the address family is going to be IPv4 unicast, then we add these ports into the VGP process. So we type network, right, and we're specifying that the loopback address 1113/32, that loopback address is now part of the VGP process. The next one is going to be 172.16.3.1, which is going to be this one right here in Ethernet 112. So now that's part of the VGP process. And then the next one that we're going to enter is going to be the IP address for this interface right here, which is going to be 172.16.6.1/30, and that is going to be the IP address for Ethernet 113, and it's right there. And then another thing that we're going to do on these spines is that we're going to establish the neighbor relationship. So if we look over here, the neighbor is going to be for router 3. The first neighbor is going to be 65020, which is router 1, autonomous system number 65020. I think it's a 4-byte address. There is also, if I'm not mistaken, an 8-byte address that can have larger ASN numbers. Let's see what else here. Then we specify no shutdown, so that now we have a relationship from router 3 to router 1. Then the next neighbor that we need to add to the process is going to be router 2. And let's check over here. Router 2 is ASN 65023, which is right here. And then the IP address for that interface, or the next hop, right, is going to be 172.16.6.2, which is right there. And then we're done with the configuration for router 3. Router 4 is going to be pretty similar, so let's not bother. Let's go ahead and check the one more configuration for leaf 1. So if I go to leaf 1 over here, I'm going to log in, admin. I'm going to go ahead and run, show running configuration and compressed. And I'm going to go straight down to the VLANs and the loopback interfaces and all that. We're going to skip the port groups. All right. So on this switch 1, which is going to be leaf 1, okay. So let's say that, like in the previous video, this leaf 1 can be, for example, in one floor, and perhaps you have leaf 2 on another part of the building, or in another building on a campus, for example. So let's go ahead and check leaf 1. So VLAN 1 is present for all the on-tag traffic. Then we have VLAN 10 that we're going to be using, right, for tag traffic. And the IP address for that VLAN is going to be 172.16.10.1.30, just to keep it, in line with this VLAN 10. So we just specified 10 right there. So this is going to be the network 172.16.10. The interface loopback 0, that's going to be the identifier for this router 1, and the identifier for that loopback address is 1111/32, just to keep it in line with 1, 2, 3, 4, right? No management interface configuration on this example. It's just a lab, and it showed the interface ranges that we talked on the previous one. All these interfaces are going to be on VLAN 1. Then let's take a look at interface 2, which is going to be this one right here, and the IP address is 172.16.3.2, which is going to be right there, and that's checked. Let's check 113, which is the one over here going to spine 2. It's going to be Ethernet 113, IP address 172.16.7.1, which is going to be this one right here, checked. And let's keep on scrolling down. And then we have interface Ethernet 114, which is going to be this interface right here. And this interface right here is going to be in switch port mode trunk, right? Because we're going to provide layer 2 capability for the downstream devices, in this case a server, and this trunk will allow us to send VLAN 1 and VLAN 10 on that trunk. Another thing we're going to be doing here is to activate the router VGP process 65020, and then we're going to specify the manual entry of the IP addresses, right, into the VGP process manually, right, because we gave these IP addresses manually. So the first one is for the loopback 1.1.1.1/32. The second one is going to be for the 172.16.3.2, and this is switch number 1, which is let's see, 3.2 is this one right here. And then finally it's going to be this other one, 172.16.7.1/30. So that's already entered into the process, so that's great. If we can keep on scrolling down, the last thing to do is to establish the neighbor relationship, and it's that easy, not complex at all. So let's go ahead and check neighbor 65021, which is going to be 65021 router 3, and the IP address for that to get to there is going to be 172.16.3.1, which is this one right there, checked. And then finally the other neighbor for router 1 is going to be router 4, which is a spine, and that spine is going to have the remote autonomous system number of 65022, checked, and the IP address to get there is 172.16.7.2, which is right there. And then we're done with that. So let's go ahead and jump to the verification. All right, so let's go there. Okay, we have well, I already ran the configuration, so let's go into verification of VGP. Okay, so let's go into switch 1 and drag this command, which is show Ipvgp summary. So I'm gonna go ahead and select this and drag it and drop it. Let me see if there's a, yeah, I think I'm gonna have to resize that. So that's gonna be router 1. So let's do it for router 2 as well. And I'm gonna have to do something here, admin, and then let's go ahead and drag the same command over here, and let's drop it. And let me just make this bigger over here, run it again, and I should be able to see that. Let's see here. So this is going to be the show Ipvgp summary, and what is happened here is that it's showing the two neighbors, 65021 and 65022. So let's minimize it. Let's check the second one in a more friendly manner, because since this is GNS3 and I'm using a virtual appliance, and I changed the font size, that's why it was all scrambled up. But if I bring the font down, I should be able to see the whole screen without having to adjust the screen. So in this case, it showed the neighbor for switch router 2 is the 172.16.4.1. It's going to be the autonomous system 65022 and 65021. So that's showing that, yep, it's established already neighbor relationships. And I'm gonna skip the others because it's gonna be working. I already checked it. And now we're gonna show Ipvgp neighbors. I think this one is gonna have more additional information. So let's go and take a look. Show Ipvgp neighbors. Let's maximize this. let's do Control C and run the command again. And let me see where. Okay, it begins over here. Okay, so this is router 1, and it's showing that the VGP neighbor in this case is 65021, right? And that the local autonomous system is 65020. Another thing that is worth mentioning is that the version for this VGP is 4. The remote router is going to be it's router 3, which is showing here 1113. Remember that on this lab we are keeping this logical. And then it gives you information about when it was established, and the whole time information. Let's see what else. Traffic information. And let me see what else we have here. Then there is the other BGP neighbor, which is going to be 114. So that's the idea of this command, is just to run to make sure that everything is working and running. So I'm going to skip that on the others just for sake of time. Then there is another one called show IP route. On this one, I think it's going to be worth doing it in a couple of routers. So let's just stick with us. Well, let's see. I want to do. That's okay. I want to do router 1. All right. So I'm going to keep it like that. Let's minimize it. Now let's go to router 2 and do the same thing. Let's go ahead and run the same command. And let's put them side by side. And it seems like it's going to be that the layout is going to be friendly enough to do all of them. So that's great. So let's do show IP route on router 3. So that's good. All right, so let's take this over here. Now let's go here to router 4 and drag the same command. Okay, all right, it's going. And then let's type. Yeah, I should have it like that. All right. Okay, so let's go here. Alright, so let's go here, and now we should be able to see the routes. It's showing the basically, like for example, if this is router 1, it's showing 2, 3, and 4. It's showing the other 3 routers. It's showing also the interface, the to get there, and then it's showing here the additional manually entered IP addresses. Let's go here. Yeah, it's basically showing because this is router 2. Now it's going to show 1, 3, and 4, and so that's what it's showing basically. Okay, so let's see. It's going to show the routes on this lab. The output should be identical. Okay, so let's see there. Okay, so that's going to be 11, and of course there's going to be, like for example, because of this one is 1, it's not going to show 1 because it's itself, but all these other ones are learned or manually enter into the process, and switch 2 is not going to show 112. Is going to just show 1, 1, 1, 1, 3, and 4. Okay, so that's working. Verification ping from server 1 to server 2. All right, so let's do that. Let's go to the server, and so let's go ahead and log in. Admin, and I think I misspelled it. Admin. Okay, yeah, it's been a long day. Beautiful day. Admin. All right, so let's open this one and let's do a ping of server 2 that is on a different subnet. So let's go ahead and ping Yeah, but I need to have this over here. Let's move this around. Let's go ahead and ping. Okay, 172. Okay, 16, 11, 2. And now it's pinging. So the BGP process is working. It was super simple to set up. Nothing hard at all, which I like. There is whenever you do IVGP, yeah, that will take. I think I'm gonna do a lab about it, just to have a scenario for that. Um, and basically I'm done with the series for these 5 getting started labs for Dell OS10.5.1, and this is going to be great for people that are considering in buying Dell networking switches that are data center class, that are proven, that can work with all the different type of workloads that Dell technologies offer, such as PowerEdge servers running VMware ESXi, for example, um, storage devices IP-based, such as PowerScale, that is basically a highly scalable NAS, network attached storage, that a lot of big data companies are using to store unstructured data, for example, and technologies such as backup disk to disk that nowadays can store to flash drives, so that way a lot of customers are buying faster networks, because not only virtualization is demanding faster networks, right? But also you have to back up all that data, right? VMs, the more VMs you have in a server, the more aggregated traffic that is going to be, being generated in each of the hosts. So you're going to need some fat pipes, right, to get out from those nodes into the top of rack switches. And then if you have to go from one rack to another, by having those fat pipes, right, you reduce the oversubscription. So the idea is to minimize that oversubscription that can happen, especially if you have a lot of east-west traffic. It's not the case on this particular lab, because this is more like, all right, so if you have servers in different buildings, different floors, you can use BGP to, so that way you don't have to manually set up the routes. So that, I think that is a plus. And I'm gonna stop right here. I don't want this to go too long, and I appreciate um, your, how to say this, interest in this type of technology. And I'm looking forward the advanced version of these labs. The next set of labs are gonna be a little bit more, not complex at all. It just require a little bit extra steps that will allow us to do multi-tenancy. It's going to allow us to do virtual um, overlay networks that will allow us to extend a layer 2 um, VLAN, for example, over a layer 3 network. So that way you can have, you can scale, for example, your east-west traffic, right? Minimizing a lot of the problematic spanning tree that happens whenever you are using a layer 2 adjacency. Um, and there is pros, there is cons, but there is more pros than cons. And as I do more videos, then I should be able to explain, when is recommended to do one type of topology versus another. And I'm signing off, and thank you for listening.